Hi children and hi everyone. In this video I am going to perform one activity that is very important for us, that is finding the focal length of a convex lens in our laboratory. So that is the method is UV method. In UV method, how we can find out the focal length of a convex lens. To do that we require some apparatus. In that the first thing is this is a biconvex lens. Biconvex lens, you have to observe clearly here. It is the refractive, so two refractive surfaces are there. There is no painting. If it is painting, there is a mirror. So now this is the lens, biconvex lens. To keep this lens we are using one stand, that is a V stand. That should be what? V stand. And now this is the candle. The flame of the candle should be taken as object, and obviously of course matchbox is also required. And this is a wooden board, cardboard, that should be taken as the screen. To capture the screen, to capture the image on the screen, we are using this one. Clear children? So these are the apparatus required. To measure the distances we require some scale also there. So generally we will use the 1 meter scale, but in my home it is only there. That's why I am going to do now the activity to find out the focal length of a convex lens. Let us go for activity now. Children, first we have to take the V stand. In that I am keeping now here convex lens. So from that lens, other side of the lens we have to keep the candle, should be like this. So here I am taking the distance now here with the help of the scale. Here this is the, now it is 20. Again I am taking, this is a 10 more. Totally here now I kept nearly 30 centimeters between the candle and candle and lens. So now here the distance what we are taken, that should be here object distance. Lens to the candle flame, lens to the candle flame is what? Object distance. So now we want to capture the screen, image on the screen. For that we have to keep some screen other side of the lens, so you can watch carefully. Here you have to observe the flame of the object. Here flame of the object is what? Candle. That flame should be taken as here object. We are bringing the screen from long distance, so we have to maintain that the candle, lens and screen must be on a line. That line is nothing but principal axis. Now I am bringing screen from long distance. You have to observe now clearly. Where we will get the clear image, there you have to stop. So again I am going back. So as this is the exactly image, up to where we will get the clear image of the flame, So what you observe now, we are getting blur image. Again I am going back. So this is the clear image, just watch it. This is the clear image of the flame. What you observed, that should be inverted image. If you can go back, you will get blur image. Come forward, blur image. At that point only we are getting the clear image. Now here, after getting the clear image, again you have to measure the distance from lens to the screen, should be taken as here V, image distance V. Children, clear? What is the procedure? From the lens to candle we are taking 20 centimeters. 20 plus 10, 30 centimeters. We are taking 30 centimeters. That should be here object distance U. Clear? So you have to imagine that the candle lens and screen should be on the same line, that should be principal axis. So after bringing the screen from long distance towards the lens, at particular one point what we get? Clear image of the flame. Now the distance between these two, I am taking now here 20 plus here 20. So approximately for value of 30 we are getting V value is 42. V value is 42. So U value means what? Lens to candle is U, object distance, and lens to screen is what it is? Image distance. So now we have to repeat the same procedure for different values. Initially what we taken? 30. Now I am going to keep here 30, 20, again 20. Here now I am giving for here 40. So now I change the U value. How much it is? 20, again 20. So now I am taking, this is the 40. So after keeping these two positions, here we have to maintain this. This is the constant. Again now we are moving the screen again from long distance to the again towards the lens. So slowly moving. So here you got the clear image. So this is the clear image of the flame. You have to observe, children, that should be inverted image. That should be what? Inverted image. So again the distance between the lens to the screen, again we have to measure with the help of the scale. We have taken 20, again now some 35 will we get, 35 we will get. So in this way we have to repeat the same procedure. So just now you saw how we can take the U value and V value. So for every time you have to change the U value, corresponding to that you have to find out the image. Then after the finding the image, you have to calculate you have to note the V value. So for every U value you are changing the U value, corresponding to that you have to find V value. So after doing so many U and V, almost all 30, 40, 45, 50 or 60, like that. So you have to take some 6 observations, and then corresponding to that you may get 6 values of V. After that every time you have to substitute the U value and V value. Already I explained in the previous video how the tabular form will be there: serial number, object distance, image distance, and 1 by F is equals to 1 by V plus 1 by V minus 1 by U. Serial number, object distance, image distance, and 1 by F is equals to 1 by V minus 1 by U. It is the lens formula. At every time you will substitute the values of U and V in lens formula. At every time you will get one focal length value. Finally, the average of all focal length values gives the focal length of the convex lens. So in this way we will find out the focal length of the lens by using the UV method. So children, I hope you understand. So if you understand very clearly, watch the video 2 or 3 times continuously, then you can easily understand the process, and you will write the examinations also very simply. Okay, right, bye, take care.